Under liability insurance, losses are uniform on 0B. There is a deductible B by 2. Calculate the ratio of variance of the claim payment from a given loss to the variance of the loss. So let the loss be X and Y be the payout. Deductible is 0.5B. B by 2 means 0.5B. And we are given that loss is uniform on 0B, therefore f of x equals 1 over b, x between 0 and b. And we know that variance of a uniform distribution is b minus a squared by 12. So b minus 0 squared by 12 equals 0.0833b squared. Y is the payout. So the payout is 0 when the loss is less than deductible. So when x is less than 0.5b. And it's equal to the loss minus deductible when x is greater than deductible and less than b, because x is limited between 0 and b. And now we already know variance of x, and we need to find variance of y, and then we need to find the ratio of the two, because ratio of variance of claim payment means variance of claim payment means variance of y, and variance of loss means variance of x. So we have to find the ratio of variance of y to variance of x. So variance of y is calculated by finding ey and e of y square. E of y, as usual, is the integral of y against f of x, and y is x minus 0.5b when x is between 0.5b and b, otherwise it's 0. So that's the only part of the integral that contributes. And here there are multiple ways of doing this integral. I've adopted the more common kind of a way. Another way is to pull 1 over b out and then just realize that this is just x minus 0.5b whole squared by 2. Maybe that's a bit shorter, but we're just learning another way here. So x over, I multiply this out into x over b minus 0.5, because 0.5b times 1 over b is just 0.5. And then the integral of this is x squared by 2b and minus 0.5x. And when you substitute x equals b, you get b squared by 2b minus 0.5 times b. And then minus, when you substitute the lower limit, it would be 0.5b whole squared for the x squared and divided by 2b minus 0.5 times x, and x is 0.5b. So 0.5 times 0.5b, and this is just b by 2. This is minus 0.5b. This is minus 0.25b by 2, because 0.5 squared is 0.25. And then this minus minus becomes plus. So this 0.5 times 0.5 is 0.25. And so all of this, simply if you remember, b over 2 is 0.5b. So these two cancel out. And so these two give us 0.125b. And this is the way in which a lot of people do this integration. I mean, you may be pulling the 1 over b out and then doing it as x squared by 2 minus 0.5bx, and it will come out to the same thing. It'll be the same amount of work. And this is a lot more work than actually we need to do. And I'll show you in the next part how you could have done this like in fewer steps. E of y square is y square, integral of y squared against f of x. And now we have a similar thing. Instead of x minus 0.5b, we have x minus 0.5b whole square. So now I'm doing it that shorter way, which you could use even in the e of y. So it's 1 over b pulled out, and then the integral of this is just x minus 0.5b whole cube by 3 when you do the u substitution on this. And so from 0.5b to b, and the advantage of doing it this way is that, look, only this x is equal to b is going to count, because that gives you a non-zero thing, b minus 0.5b whole cubed by 3. But when you put x equals 0.5b, that just becomes 0. And it's a lot less work than the method that we commonly use. So this is 0.5, b minus 0.5b is 0.5b and whole cube. So 0.125 is the cube of 0.5, and b cube over b is b squared. So variance of y, be of y squared, which is this, minus ey whole squared. So ey was 0.125b, and this simplifies to 0.2026 b squared. And we needed variance of y ratio variance of x. So you divide variance of y by variance of x, that's 0.3125. And the answers that are given are in terms of ratios, and 5/16 is the fraction that is equal to 0.3125. So the ratio is 5:16. That's choice D.